Okay, this is just going to be some practice for what we went over in class. It's nothing really new, but it's just a way for us to practice and look again at our polyatomics in just a different way. So some of these we've already done. So O2, we know it's 6 plus 6, so I have a total of 12 electrons. And like I sort of showed you in class, you have 12 to do whatever you want with. And so we did this, and then 1, 2, 3, 4. So I have 2, 4, 6, 8, 10, 12. And that's not working out because this guy has 8, but this guy doesn't have 8. And so whenever that's the case, that's when we need to double bond. Okay, so I'm going to pull 2 electrons from here, and then I'm going to go ahead and shift them over here. So I now still have 2, 4, 6, 8, 10, 12 electrons, and that's my double bond. Okay. The same thing occurs when I look at CO2. So I have my 6 plus 6 plus 4 now. So I have 12 plus, so I have a total of 16. And so I have C, and if I go ahead and I start setting this up, 2, 4, 6, 8, 10, 12. I have 4 more electrons to use. Well, if I put them just on carbon, then my oxygens aren't going to be good. If I put them here, so ultimately I end up double bonding here. And then N2, which we also did as an example, is 5 plus 5. So I have a total of 10 electrons. If I go ahead and I bond them, 2, and then I only have 8 electrons left, which is really only enough for 1 nitrogen. So I'm ultimately going to end up with a triple bond. There's 6, 7, 8, so that's a bad electron, 9, and 10. Okay, so that's just a little review of our double and triple bonds. So now what I'd like you to do, and I gave you a list on the front page of a list of polyatomics to try to draw. It'd be a great practice for you to try to draw them out yourself and then watch me solve them. So if we're looking at hydroxide, and hopefully you've already tried it, the one thing that we have to keep in mind is that these polyatomics have a charge. And so I have 6 plus 1, but this minus 1 is adding 1 more electron in there. That's what it means. So I actually have 8 electrons for this to work. So I'm going to take oxygen, I'm going to bond it to my hydrogen. So I have 2, 4, 6, and 8. And anytime I draw something that has a charge, I'm going to throw some square brackets around it and add that charge in. So I know that that overall polyatomic has a charge. If I look at something like chlorate, which is ClO3 minus 1, well, I have my 7 from chlorine. I have 6 times 3 for oxygen, so I have 18 from oxygen, and then I have that one more one that's hanging out there. So I'm at 26. So let's go ahead and put Cl, O, O, O. I'm all the way up to, so I have 26. So there's 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and I have 2 more, which is good because chlorine doesn't have enough, so 26. So if I look at this one and this one, if we go back and look at shape, 2 points, so this is linear. And if I look at shape here, I have A, I have 3 things around it, A, X, 3, and E, and so I have trigonal pyramid. Now that I've gone over the first 2, if you haven't drawn the other ones that are listed, I suggest you pause the video and try to draw them before you watch my solutions. Sulfate, let's try that one, SO4, negative 2. So we have 6 for the sulfur. I have 6 times 4 is 24 for my oxygen. I'm just sort of combining that there. And then I have minus 2, so I have another 2. So I have a total of 32. Put my S in the center, oxygen, 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 oxygen. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Lovely. It works out perfectly. I square bracket it to indicate that it has a charge. It is AX4, and so it is tetrahedral. And then if I look at sulfite, SO3, -2, I have 6 times 3, so I have 18 oxygens. Okay, plus another 6, plus another 2, which is equal to 26. If I'm going to go ahead and draw this one out, I'm going to do S, oxygen, oxygen, oxygen. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Go ahead and do this. -2. And now I have A for my center element, 3 things around it, AX3E, and I'm looking at trigonal pyramid. Okay, we've got 4 more. So we have phosphate, okay, PO4, -3. And so I'm looking at 6 times 4, I'm looking at 24 for my oxygens, plus 5 for my phosphorus, plus the extra 3, so I'm up to 32. Put my P in the center, O, 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 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 4, 26, 28, 30, 32. Easy peasy, we're done. We'll just put that around it. A, 4 things around it, AX4, so we're looking at tetrahedral. Carbonate, okay, CO3, -2, so I'm looking at 6 times 3, or 18 for my oxygens, plus 4 for my carbon, plus the 2 for my electrons, so I'm looking at 24. So I have C, I'm going to go O, 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 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That's good, except carbon doesn't have enough. And as soon as I look at it and I see that one thing doesn't have enough, it's telling me that I need to double bond. So let's take these guys off here. And then let's throw that in. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Wonderful. -2. And then I have 3 things around it, so we are trigonal planar. So that was AX3. 2 more. Nitrate, NO3, -1. So if I'm looking at this, I have 6 times 3, I have 18, plus 5, plus 1 equals 24. Put my N in the center, O, 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 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. It's great again, except I don't have enough on nitrogen. So let's remove 2. And it wouldn't matter, I just happened to be picking that same one all the way on the right, but it wouldn't matter which one that you double bonded. That's that idea of resonance, that it doesn't matter which one you double bond because it's all the same. And again, it's AX3, trigonal. Here. Last one, let's see how it compares to nitrite, NO2, -1. So now I'm looking at 12 plus 5 plus 1, which is equal to 18. So I have N, O, and O, 2, 4, 6, 8, 10, 12, 14, 16, 18. Oh gosh, it's almost good, except nitrogen doesn't have enough. And so in this case, let's just go ahead and pull some electrons off one of those O's. I'm going to pull from this side this time to show you that it doesn't really matter. Kick that in as a double bond. Everybody now has 8, 2, 4, 6, 8, 10, 12, 14, 16, 18. Lovely. -1. And I have A, X2, 1, 2, E, so I'm looking at bent. Last thing I have for you here, metallic bonds. Okay, it's great because we don't have to draw anything for metallic bonds. These are when metals bond with metals. So we have already done metal plus non-metal equals ionic. We have non-metal plus non-metal, which equals covalent. And then when we have metal plus metal, we have metallic. This allows electrons to be delocalized, which means they can move from one to another. That's good because metals conduct electricity, and that's why, because those electrons can move. Metals are malleable, which means we can hammer them into thin sheets, and ductile, which means we can draw them into wires. They are insoluble, which means they do not dissolve. So that's where we're going to stop. These are some of our properties of metallic bonds. We don't draw them, which is just lovely. We just know that when we say something like Fe, that it's bonded to other Fe's. This is what we're talking about with solid metals by themselves. And that'll end our unit on bonding.